The screen in front of you and the chair you're sitting in exists as a construction. Your biology interprets raw data, meaning physical reality is less direct than it feels. Your brain is a 3-pound mass of wet tissue. It spends its entire existence locked away inside a pitch-black, completely silent vault of bone. Because it has zero physical contact with the outside world, no light ever reaches it and no sound ever penetrates the skull. It survives on a chaotic stream of electrical spikes traveling up your nerve fibers. Neuroscientist Jeff Hawkins developed the thousand brains theory to explain how intelligence emerges from this biological isolation. A sensory blackout defines the interior of the skull. Yet the experience you are perceiving right now is seamless, full color, and three-dimensional. Every detail you perceive is a generative forecast. The brain simulates the world to stay ahead of the data, predicting reality to keep you alive. The neocortex, a crinkly sheet of tissue taking up 70% of your skull, is the seat of human intelligence. It is a single type of brain tissue that governs everything from language to abstract thought. Under a microscope, this tissue reveals a repeating architecture. The neocortex is divided into tiny vertical structures of neural wiring. There are 150,000 of these cortical columns. Each one resembles a tiny piece of spaghetti standing upright like a Roman column. These columns operate as independent mini-brains. Each possesses its own dedicated sensory inputs and its own motor connections, allowing it to act on the world autonomously. They use physical movement to test their surroundings. By flitting your eyes or moving a finger, these columns actively guess what sensation will arrive next. Intelligence functions as a massive, decentralized network. These 150,000 tiny prediction engines work in parallel, creating a collective outcome rather than a single conscious stream. This prediction engine operates in real time every time you interact with a familiar object, like a coffee cup. As you run a finger along the rim, the brain anticipates the sensation of smooth porcelain. It maps the expected texture milliseconds before your skin actually touches the surface. The process changes if your finger encounters a hidden crack in the ceramic. When the physical prediction fails, the cortical columns experience a sensory error. The brain instantly updates and recalculates its model of reality to account for the surprise. Now, this mapping applies to entire environments. Walking through the hallway of your home is a rehearsal of anticipated sensations based on your stored model of that space. Navigating a room is an act of walking through a pre-rendered simulation. Your brain builds this model to avoid physical surprises, updating the rendered space with every step you take. This decentralized architecture changes how we define the self. Since each cortical column contains its own unique model and frame of reference, your perception is physically fractured. The brain is actually thousands of independent mini-brains observing different slices of reality at once. These independent units reach a consensus through a microscopic voting system. The columns generate conflicting models of the outside world and must literally vote on what is happening. The winning vote surfaces as your conscious experience. This process masks the biological debate happening in the dark just beneath your perception. Normal life feels smooth and continuous, but it relies on a fragile voting mechanism that updates thousands of times per second. If everything you experience is a filtered simulation running inside a dark skull, how can you be absolutely sure you are awake right now?